Hey everyone, and welcome back to the Deep Dive. Today, we're going deep into the world of databases.
Ooh, fun.
Specifically, SQL and NoSQL.
All right.
You hear databases and you think, oh, that sounds kind of dry.
Yeah.
But in our data-driven world, understanding how information is stored and managed,
Right.
it's super crucial. It's the backbone of everything online.
Yeah, it really is. I mean, think about it. Every time you, a post on social media, buy something online, stream a video, you're interacting with a database.
Oh, for sure.
But not all databases are made equal.
Okay, so let's break this down.
Yeah.
We've got SQL and NoSQL, two big players.
Yeah.
Now, I know SQL stands for Structured Query Language.
That's right.
And it's been around forever, right?
Yeah.
Kind of like a reliable grandpa.
Yeah, that's a good way to put it. It emerged in the 1970s.
Wow.
And it's all about organizing data in a very structured way, like a perfectly organized spreadsheet.
Got it.
Tables with rows and columns.
Okay, so very structured.
Yes, and this structure makes it super reliable for systems where accuracy is paramount.
Ah, so that's why SQL is used for things like banking,
Exactly.
where even a tiny error could be disastrous.
Right.
What's so special about SQL, though, that makes it so reliable?
So it all comes down to ACID compliance.
ACID compliance.
ACID stands for Atomicity, Consistency, Isolation, and Durability.
Okay.
It's basically a set of rules that guarantee data reliability.
Yeah.
So, for example, imagine transferring money online.
Right.
ACID compliance ensures that the entire transaction is completed without any hiccups.
Okay.
Your account balance is accurate,
Right.
and that the changes are permanent.
So there's no room for error.
No room for errors there.
For those banking systems where, a tiny error is catastrophic,
Yeah,
SQL's ACD and compliance is a must-have.
definitely.
Got it. But what about NoSQL? Where does it fit in?
So NoSQL came about as a response to the massive explosion of data that we've seen in recent years, particularly unstructured data. So think social media feeds sensor data from your smartwatch. Just mountains of information generated online.
Yeah, that's a lot.
Every second. And SQL just wasn't designed to handle that volume and flexibility.
So NoSQL is like the agile younger sibling built for the age of big data.
Exactly. NoSQL databases prioritize speed and scalability.
Okay.
And they can handle data that doesn't fit neatly into rows and columns,
Gotcha.
like we see with SQL.
Right.
It's all about flexibility and performance, especially when you're dealing with constantly changing data.
This is where it gets juicy.
Yeah.
Tell me more about these different types of NoSQL databases.
So there are four main types.
Okay.
We've got document stores, key value stores, column stores, and graph databases,
Wow.
each with its own strengths depending on what you need it to do.
Okay. I'm ready to dive deeper. Let's unpack these NoSQL types one by one.
Okay, let's start with document stores.
Right.
Imagine storing information like in separate folders, each containing all the relevant details for a specific entity, like a customer profile or a product in an online store.
Right.
That's essentially what a document store does.
Got it.
And they often use a flexible format like JSON.
So instead of breaking down information into separate tables like SQL,
Yes.
document stores keep everything together in one place.
Precisely.
Okay.
This makes document stores perfect for applications that need to store and retrieve complex data structures,
Okay.
like a user profile with all their activity preferences, connections.
So think like social media profiles or your Netflix viewing history.
Yeah, great examples.
Got it. So document stores are great when you need flexibility
Yes.
and you don't want to be constrained by rigid tables.
Right.
What about those key value stores? The name itself sounds kind of intriguing.
Yeah, they are all about simplicity and speed.
Okay.
Imagine looking up a word in a dictionary.
Okay.
You provide the word, the key, and instantly you get the definition, the value.
Ah, so it's like Amazon instantly retrieving your product details
Yes.
with a single click.
Exactly.
That's a key value store in action.
You got it.
Ah.
Key value stores are incredibly efficient for quickly grabbing specific pieces of data.
Okay.
They're often used for caching frequently accessed information,
Okay.
like product details on an e-commerce site,
Gosh.
or user sessions to keep track of who's logged in.
Okay, I'm starting to see how these different NoSQL types cater to very specific needs.
Yeah.
What about column stores? What makes them unique?
Column stores are the data warehousing champs.
Okay.
Think of it this way. If SQL is like a spreadsheet with data organized by rows,
Right?
column stores are like looking at that same spreadsheet, but focusing on the columns.
Okay, interesting.
Yeah.
So if you need to analyze specific pieces of information across millions of entries.
Yes.
Like finding out the average age of users who bought a specific product.
Right.
Column stores would be more efficient than SQL.
You got it. They're perfect for analyzing trends and patterns in massive data sets.
Okay.
Think analyzing website traffic patterns, user behavior on an app, or even processing data from thousands of sensors in real time.
Okay. All right. So we've got document stores for flexibility, key value stores for speed,
Yes.
and column stores for analyzing massive data sets.
Right.
That leaves us with graph databases. What's their superpower?
Graph databases are all about relationships.
Oh.
They're like those detective boards with photos and strings connecting them.
Oh, yeah.
But for data.
Interesting.
They excel at mapping and querying connections between different data points.
Okay.
So think social networks, recommendation engines, or even mapping out complex supply chains.
So if you want to figure out who's connected to whom on Facebook,
Yes.
or recommend products based on a user's past purchases,
Exactly.
a graph database would be the way to go.
Yeah, they provide a powerful way to visualize and analyze complex relationships,
Right.
making them invaluable for applications that rely on understanding those connections within data.
Wow, this is fascinating stuff. I'm starting to see how choosing between SQL and NoSQL and even between the different types of NoSQL, it really depends on the specific problem you're trying to solve.
You're absolutely right. There's no one-size-fits-all answer in the world of databases.
Right.
It all comes down to understanding the nature of your data, the performance you need, and what kind of questions you'll be asking of it.
So how do you go about making that decision? Is there like a roadmap for choosing the right database?
There is. But before we map out that decision-making process,
Okay.
maybe we can take a quick break
Sure.
and then come back to explore how to choose the perfect database for your needs.
Sounds good.
All right.
We'll be right back after this. Welcome back to the Deep Dive. Before the break, we dove into the world of SQL and NoSQL.
We did.
Got a taste of their strengths.
Yes.
And the different flavors of each.
That's right.
Right. And we even explored those 4 fascinating types of NoSQL databases.
Yes.
Document stores,
Yes.
key value stores, column stores, and graph databases.
We did.
Now, let's get down to brass tacks.
Okay.
How do you actually choose the right database for a specific project?
Yeah, it's like you're standing in a database supermarket
Right.
with all these options
Yeah.
staring you in the face.
So where do we even begin? What are the key factors to consider?
So first you got to think about your data.
Okay.
Is it structured, like customer information with clear fields?
Mm-hmm.
Or is it more unstructured, like social media posts
Okay.
with text, images, and videos all mixed in?
So if it's neat and tidy, data SQL might be a good fit.
Right.
But if it's more free-flowing and diverse, NoSQL could be the better choice.
Exactly. Next, consider how much data you're dealing with
Okay.
and how fast it's growing.
Mm-hmm.
Do you need a database that can scale effortlessly as your data explodes?
Right, because some databases are better suited for handling massive amounts of data than others.
Yes.
It's like the difference between a small car and a heavy-duty truck.
Exactly.
You wouldn't use a car to haul a ton of bricks.
Right. You need the right tool for the job.
Exactly. Then think about performance.
Yes.
How quickly do you need to access and process your data?
Right. Are we talking milliseconds?
Or can you afford a little more time?
So if you're building a real-time application like a stock trading platform where every millisecond counts,
Yeah,
you need a super fast database.
you got it.
And finally, consider the complexity of the relationships
Yes.
within your data.
Right.
Are you dealing with simple connections, or do you need to analyze complex networks of relationships?
Exactly like in a social network or a recommendation engine.
Okay, so we've got data structure, volume, performance, and relationships.
Yeah, those are the big ones.
Those are some major factors to weigh.
Yeah.
But let's get even more practical.
Okay.
Can we break down some specific scenarios?
Sure.
And see how these factors play out in real life?
Yeah. Let's imagine you're building an e-commerce website.
Okay, cool.
You need to manage customer information, process orders, track inventory,
Yeah.
and maybe even provide personalized recommendations.
So you've got a mix of structured data like customer names and addresses,
Right.
as well as more dynamic data like product catalogs and browsing history. Exactly. And you need a system that can handle transactions reliably, ensuring that orders are processed accurately
Right.
and inventory is updated correctly.
So in this case, SQL, with its ACD compliance,
Yes,
would be a solid choice
it would.
for managing those critical transactions and structured data.
Yes, definitely.
Right. Because you don't want any glitches when people are spending their hard-earned money.
Yeah, for sure.
But what about those product catalogs and recommendations.
Yeah.
Wouldn't NoSQL be a better fit for that?
You're thinking like a true database architect.
Haha.
For managing the product catalog with its diverse attributes,
Right.
images, and reviews,
Okay.
a document store like MongoDB would be ideal.
Gotcha.
Its flexibility makes it easy to handle the ever-changing nature of product information.
And for those personalized recommendations, we could tap into the power of a graph database like Neo4j, right?
Spot on.
It could analyze customer purchase history and browsing patterns
Exactly.
to suggest relevant products.
Graph databases are masters at uncovering those hidden connections within data, making them perfect for powering recommendation engines.
So in this e-commerce scenario, we've got a beautiful blend of SQL and NoSQL, each playing to its strengths.
Exactly. It's a database dream team.
I love it. But what about a scenario where NoSQL might be the primary choice?
Okay, so let's imagine you're building a mobile gaming app with millions of users worldwide.
Okay, cool.
You need to track player progress, manage in-game purchases, and handle real-time interactions between players.
So you've got massive amounts of data coming in from all over the world.
Yes.
And you need a database that can handle that scale and speed.
Exactly. And the data structure can be quite complex with different game levels, items, player stats, and social interactions.
In this scenario, a NoSQL database would be the clear winner.
It would be.
But which type of NoSQL would be the best fit?
Yeah, that's the question.
It seems like we'd need a bit of everything.
You're right. For storing player data and game progress, a document store like MongoDB would be perfect. It can easily handle the diverse and evolving nature of player profiles.
And for managing those in-game purchases, where speed and reliability are paramount, we could use a key value store like Redis, right?
Precisely. Redis is like the Usain Bolt of databases.
I love it.
Perfect for those lightning-fast transactions.
Okay.
And to handle those real-time interactions between players, like chat messages or in-game events, we could use a combination of Redis for speed and maybe even a graph database like Neo4j to track the relationships between players in a multiplayer game.
So we've seen how SQL and NoSQL can work together in harmony.
Yes.
And we've seen scenarios where NoSQL takes the lead.
Right.
But I'm still curious about those hybrid solutions we talked about earlier.
Yeah.
When would those come into play?
So hybrid solutions are perfect when you need the rock-solid consistency of SQL for certain parts of your application. But you also want the flexibility and scalability of NoSQL for other parts.
Okay, so like a system that needs to manage financial transactions with absolute accuracy, but also needs to handle massive amounts of user-generated content.
You got it. So you could have SQL handling the money side of things, while NoSQL takes care of the more dynamic and unstructured data.
Makes sense. A platform like Couchbase combines the strengths of both SQL and NoSQL.
It does.
Offering a versatile solution for those complex scenarios. Okay, so we've got SQL, NoSQL, and even hybrid solutions.
We do.
It's clear that there's no one-size-fits-all answer when it comes to databases.
That's right. The key is to carefully analyze your specific needs. Considering factors like data structure, volume performance, and the complexity of relationships within your data.
It's about understanding the strengths and limitations of each approach. And choosing the best tools for the job.
Exactly. And don't be afraid to experiment.
Okay.
The world of databases is constantly evolving.
So stay curious, keep learning. And don't be afraid to try new things.
This has been incredibly insightful. I feel like I've leveled up my understanding of databases big time.
Glad to hear it.
But before we get too carried away, let's move on to talking about some real-world examples of how these database systems are being used in practice.
Sounds good.
Welcome back to the Deep Dive. We've explored the ins and outs of SQL and NoSQL, and even dipped our toes into those hybrid solutions. But now let's see how these database powerhouses are actually used.
Let's bring these concepts to life. With some real-world examples. Think about a platform like Netflix. Millions of users streaming movies and shows, generating tons of data about viewing habits, preferences, ratings.
Netflix is a data goldmine.
Oh, yeah.
They must be using some serious database magic.
They do.
To handle all that information and provide those personalized recommendations. Absolutely. They use a blend of SQL and NoSQL to make it all work.
Interesting.
So, for example, they might use SQL to store user account information. Like billing details and subscription plans, ensuring that sensitive data is managed securely and reliably.
Makes sense. You want those transactions to be smooth and secure.
Right.
So SQL's the perfect fit.
Exactly.
But what about those recommendations? That's where NoSQL comes in, right?
You got for tracking what people are watching,
Okay.
building user profiles and generating those because you watched suggestions.
Yeah.
They might use a document store like MongoDB.
Okay.
It can handle the massive volume of viewing data
Right.
and the complex relationships between users, shows, and preferences.
So it's like SQL lays the foundation with reliable user accounts.
Yeah.
And then NoSQL steps in to provide a personalized experience based on individual preferences.
Exactly. It's a perfect example of how different database types can work together to create a seamless and engaging user experience.
I like it. This is amazing. It's like seeing behind the curtain of these apps and understanding the technology.
Yeah.
Do you have any other real-world examples?
Yeah. Let's shift gears to the world of online gaming.
Okay.
Think about massive multiplayer online games.
Okay.
MMOs, where thousands of players interact simultaneously.
Okay, I'm picturing a game like World of Warcraft.
Yeah, perfect example.
Where there are so many players, quests, items, events happening all at once.
Right.
The amount of data they must be processing is mind-boggling.
It is, and to handle that complexity, they often use a combination of NoSQL databases.
Okay.
For example, they might use a key value store like Redis
Okay.
to manage real-time events.
Okay.
Like player movements, actions, and interactions.
So Redis is super fast.
Oh, yeah. It ensures that the game responds quickly to every click and command.
That makes sense. You wouldn't want any lag when you're battling a dragon or competing in a race.
Exactly.
But what about those more persistent aspects of the game, like character stats, inventory, and progress?
For that, they might use a document store like MongoDB, which can easily store and retrieve complex data structures, representing characters, items, and game worlds.
Gotcha.
And to track the relationships between players, guilds, and alliances, they might even tap into the power of a graph database like Neo4j.
So it's another case of different database types working in concert to create a rich and dynamic gaming experience.
Exactly. It's a testament to how choosing the right database can make all the difference in building a successful and engaging application.
This has been a truly eye-opening deep dive into the world of databases.
It has.
From SQL's reliability to NoSQL's flexibility. We've uncovered the strengths of each approach.
We have.
And seen how they play crucial roles in the apps and services we use every day.
That's right. Remember, there's no one best database.
Right.
It all comes down to choosing the right tool for the job.
Yeah.
Understanding the nature of your data and considering factors like performance, scalability, and the complexity of relationships within your data.
Absolutely. And with the rise of hybrid solutions, multi-model databases and cloud-based offerings, the database landscape is constantly evolving.
It is.
Offering even more options and possibilities for developers and data enthusiasts.
So keep exploring, stay curious, and never stop learning.
Okay.
The world of databases is full of fascinating discoveries waiting to be made.
Well said. And on that note, we've reached the end of our deep dive.
Okay.
We hope you've enjoyed this journey into the world of databases.
Yeah.
Until next time, keep those data-driven minds engaged.